Hello, year eight. How you going? Today we're going to be looking at a geometry review, a bit of revision of the geometry that we did last term. So last term we did geometry, and then we looked at congruence, and then we also looked at transformations. So they're sort of similar topics with some slightly different things. Today we're just looking at geometry. We're going to be looking at quadrilateral and triangle rules. We're going to look at parallel line rules as well. Obviously, these questions don't contain everything you need to know. They're just a few examples to help you with the work for today. So first one here, we've got to find the value of x, and we're going to give reasons. Okay, so remember, with geometry, you're going to have a line of working, and then in brackets, you've got to justify why you know that to be the case, giving a reason. And you've got to be sufficiently detailed in your written reasons. So just make sure that your words are clear, succinct, but also contain enough detail for you to for what you're saying to be true. So in this one here, I see x is a part of a quadrilateral, and I know that quadrilaterals angle sum always adds to 360. So I know that x will be equal to 360 minus all of the other angles. So 72 minus 113 minus 90. And in brackets, the reason is angle sum of a quadrilateral. Okay, so I've done my working, I've done my reason, and then I can pop this in my calculator and I'll get my answer. 360 minus 72 minus 113 minus 90 will give us our answer of 85. Okay, so it's 85 degrees is our value of x. Working, reason, and then answer. For this question here, we're going to write an equation and solve it to determine the values of the unknown angles. So I can see inside the triangle, I have three angles. I know that the angle sum of a triangle is 180. So again, working, reason, and then next step. So I know that 2x minus 4, which is one of the angles, okay, plus 4x plus 52 is going to equal 180, and my reason is angle sum of a triangle. Now, these brackets that I put in are just cosmetic. They're just there to see that that's one of the angles, and then I have the other two angles there. They don't actually do anything. They're not functional, so I can treat as if these brackets were not there. If you prefer not to write them there in the first place, you can, but you just know that you can mathematically work without them. So 2x plus 4x becomes 6x, okay, and then 52 minus 4 becomes plus 48, and that equals 180. Now for this step, I don't need a reason because all I've done is collected like terms, okay? We don't need to justify all our algebraic steps. It's only the ones that have some sort of geometry fact. So the fact that these add up to 180 is due to a geometry reason. So I need to write a reason for that. So that's 180, I should say. And then 6x is going to be 180 minus 48. So we just plug that in here. We get our answer 132. And then we're going to divide that by 6. Whoops. Oh no. Divide by 6. Let's see if this works. I get 22. So x equals 22 is my answer. Again, of just working through solving an equation. Now, to find out what y is, I can see that y is on a straight line with 4x. So I can say 4 times 22 equals 180 minus y. Or actually, a better way of putting this would be y equals, let's make it a bit easier, y equals 180 minus 4 times 22. Okay, because x is 22, we found that in the previous line, and our reason is angles on a straight line. On a straight line are supplementary. Are supplementary. Okay, so because that was a geometry step, I had to write a reason in brackets, but then I can solve this without this. So I can just pop it in my calculator, and it's going to be 92, I believe. Let's see how good my mental maths is. Minus 4 times 22. There we go. Okay, so for these ones, you had to do your geometry reason, and then you have to work through your equations to solve your to find your answer. Okay, for these ones, we've got some parallel lines. You see these arrows, and straight away we're thinking we're going to have to use some parallel line laws. So we've got to think about a few things. We've got to think about alternate angles that make a Z shape. We've got to think about corresponding angles that make an F shape. We've got to think about co-interior angles that make a C shape. Co-interior being the supplementary ones. We might also have to look at vertically opposite angles, but we'll see how we go. So for question A, the first thing that I can see is this x1 is reasonably easy. So x is going to be 180 minus 110, and that's just going to be angles on a straight line. Supplementary. Okay, not too hard there. And then that equals 70. So we've got x already. And I know that y is corresponding. So y is also going to be 70, okay, because it's corresponding with x. Corresponding angles on parallel lines are equal. And then to find z, okay, I need to do an angle at a point, or angles of a revolution. So I can say z equals 360, because that's how much a revolution is, minus 160 minus 70. Okay, that's angles at a point. And so 360 minus 160 is going to be 200. And then 200 minus 70 is going to be 130. Okay, so there we go. We've got our 3 pronumerals for A. I'm not going to do all of the other ones. You can have a go at those if you would like, or you could just get on with today's work. But you can see the different kind of reasons that we could use. So for example, we could find C using so I'm just going to do it sort of quickly, not in full. C, we could use angle sum of a triangle, and then we could find B because it's alternate with 60. We could find D because it's alternate with 40. So C is going to be 80. B is going to be 120. And then, sorry, would it be 120? Is that right? Something along this. No, sorry, it's going to be alternate with 60, so it'll be 60 as well. That makes more sense. Yeah, so B is 60, and then D is going to be 40. And then we could find A, we've got corresponding, so A is going to be 40, and then E, we could do angles at a point. So you get the idea, lots of different reasons that we could use for this one here, and similarly for C. Okay, final questions. Here we have different quadrilaterals, and we've got to remember the properties of our quadrilaterals. So we know that parallelograms, okay, that their diagonals are bisected. They're not bisected at right angles, but it means that the lines that go across are cut in half by the other diagonal. So that means x is going to be 2.8 centimeters and y is going to be 3.5 centimeters. And then my reason is diagonals of a parallelogram bisect each other. Okay, And then for B, I have a kite. And I've got to look at what I'm trying to find here. So I've got side lengths of a kite. I've got some angles inside the kite that I'm also trying to find. So let's see how we go. For X, okay, I know that X is going to be 4, okay, because short sides, or adjacent sides, I should say, sides of a kite are equal. And then let's do Y next. So Y is also going to be 7 centimeters, okay, because the long adjacent sides of a kite are equal. And then Z is going to be an angle. Now, I know that angles of a kite bisect each other at right angles. Oh, sorry, diagonals of a kite bisect each other at right angles. So that's going to help me find that missing angle there. So in this instance, Z is going to be 180 minus 65 minus 90. And I've got sort of two reasons here. So I'm going to say diagonals of a kite bisect each other at right angles. Or diagonals of a kite, another way I could say this is diagonals of a kite are perpendicular. Okay, because that means they make a right angle. My other reason is angle sum of a triangle. That's how I got the 180 minus. Okay, so then I get 90, and then it's going to be 25 is going to be Z there. Okay, now I've got to think about these two angles here, and I know that opposite angles, okay, of a kite on the short diagonal are equal. So I know that V plus 65 equals W plus 75. So what's going to happen here is that I know that W is going to be 65 and V is going to be 75 because that's the component of the angle that it's opposite. And my reason is opposite obtuse angles of a kite are equal. Okay, so there's lots of different reasonings that we've got to do there, but there we have it. Good luck with today's work. I'll see you later.